pertinent to think about because it thinks of things as polar molecules, nonpolar molecules, or ionic compounds. And there are 5 of these on your homework, and we'll do at least the first, well, we'll do at least a couple of these. And your process for these, well, is always, or you can always think of it as, first off, draw the best Lewis structure. Then draw or think about dipoles. And then come up with your answer. So for ammonia, NH3, if you draw the best Lewis structure, it would have NH3 like this. And our process would be, well, there are dipoles in here. Those dipoles never face the hydrogen. They always point towards whatever hydrogen is bonded to. There are 3 dipoles. There's a pair of electrons. Those dipoles cannot possibly cancel. This is a polar molecule. Now H2O. H2O, I'm going to suggest you don't have to do any of this for H2O. The reason being that H2O is a polar molecule, it is a polar molecule, it is a polar molecule, and I would suggest that you're learning a lot this semester, but the most important thing you're learning this semester and solidifying why the reasons are is that H2O is a polar molecule. And I've jokingly referred to my students on previous semesters on their exams that if you answer nonpolar or ionic for H2O, I will take away 1,000 points. Minus 1,000. But of course I would never do that because we always make mistakes, or it's always a possibility. But I will say that polar molecule H2O must be your answer. And of course, if we go through this process of drawing the best Lewis structure, we see, and drawing dipole arrows, well, it can be a little tricky actually if you draw them opposite each other because they can look like they're going to cancel, but we know that water has a tetrahedral shape and it has dipoles that are at an angle that do not cancel. Water is a polar molecule, like so. Well, 2 more examples. Carbon tetrachloride. If we draw its Lewis structure, it is going to have all chlorines around the carbon. Any dipoles that exist, which there are dipoles, are in exactly opposite directions. This one's going to be nonpolar. And finally, lithium nitrate. Anything that has a metal in it or has the ammonium ion is going to be ionic. So that's how you recognize those. All right, any questions about that?